Hello everyone, in this problem we are given a matrix and a list. The matrix, which is called grid, has n rows and m columns, and it is filled with unique numbers from 1 to m by n. In other words, the grid is filled with exactly one of each number from 1 to m by n. The second input is a list, which is called paintings, and it's also filled with exactly one of each number from 1 to m by n. The array represents the spot in the grid that we will paint in the order that we will paint them. So for this first example, the first position that gets painted at time 0 is the 4. Next, at time 1, the 8 gets painted. Then at time 2, the 3 gets painted, and so on. Our goal is to find the earliest time where either an entire row or entire column has been painted. So for this example, when we paint the 6 at time or index 3, we fill out the entire first column, so this time/index would be what we return. Some constraints of the problem are that both the length and width of the grid will be at least 1. The length of paintings is going to be the height multiplied by the width of the grid. And finally, the elements of the grid and paints array are filled with exactly one of each number from 1 to width times the height. Okay, now that you hopefully understand the problem and this example, let's get into the first solution, which is going to be a simulation. For each element in the paintings array, we mark that position in the grid as painted. Since this newly painted position possibly completes the row or column, we will check if this particular row or column has been completely filled in. So if we look at this example from earlier, when we paint the 4, it is on the first column and second row. So we would iterate through these rows and columns to check and see if they are completely filled in. It isn't, so we move on to painting the next number. Let's look at the code. First, we save the width and height of the grid for convenience. We also initialize a matrix called painted, which is the same dimensions as the grid. It holds booleans, which represent whether or not this grid has been painted. At first, they all start as false, as none of the grid has been painted. Next, we initialize a map called value to position. This is a map where the key will be the value in the grid, and the value will be a pair of integers representing the position in the grid. This map will allow us to access where an element is in the grid in constant time. Next is the simulation part. We iterate through each element in the paints parameter, and we paint the position of the element by looking up the position in the value to position map, and then marking it as true in the painted Boolean grid. Next, we check if the whole row has been painted by iterating through each column in the row, and if any element has not been painted, we mark the whole row painted variable as false and break out of the for loop. Later, we can check if this variable is true, and if it is, we return this ith index, because this is the first index a whole row or whole column has been painted. Before we do that though, we also check if the whole column is painted, and if either the whole row or whole column is painted, we return I. And finally, there is a small statement here returning -1 just to tell the compiler we are returning something. But in reality, given the constraints of the problem, we are guaranteed that we should find a row or column completely painted eventually, so we should never reach this line of code. Let's now analyze the time and space complexity of the code. If we let n be the height of the grid and m be the width of the grid, then the time complexity of this solution is n times m times m plus n. The n times m comes from iterating through every element in paints, and the m plus n comes from the fact that while we are iterating, we have to iterate through a row and column each time to check if the entire row or column has been filled. The space is n by m for the painted Boolean grid. Okay, that's it for the first solution. Let's try and improve the time complexity of this solution by getting rid of the extra m plus n. As we just saw, the part of the first solution that was costing m plus n would be this section here, where we iterate through the row and column to check if they have been completely filled. We need an alternative way to check if the whole row or whole column has been painted that can be done in constant time. We can do this by keeping track of the amount of positions that have been filled per row and column. So let me paste the code of the second solution to show what this looks like. We have two arrays, filled row and filled column. For each element in these arrays, it represents how many elements for that row or column have been painted so far. Then in our for loop, instead of checking by iterating, we increment these arrays for the corresponding row and column. And if the count for this column is equal to the height, it means that all positions for this column have been painted, so we can return I. Or, same thing for the row, if the amount of row positions that have been painted for this row is equal to the width, the whole row has been painted, so we return I. The code might be a bit confusing, so let me walk through our earlier example so I can elaborate. So to start off, both the painted row and painted column arrays are all zeros. Painted rows has 3 elements because that is the height, and painted column has 4 elements because that is the width. Let me also paste the for loop code block so we can reference it as we trace. At time 0, the 4 gets painted, so paint row and paint column are 1 and 0, so we increment those positions in our painted arrays respectively. Neither of the if clauses are true because the painted arrays are both equal to 1, which is not the height or width. So we move on to the next iteration. I'll move a bit faster now. On the next iteration, 8 gets painted, and the row and column position of the 8 are 0 and 0, so we increment those in the painted arrays. Once again, the if statement is false, so we move to the next iteration. Next, the 3 gets painted, that is at row index 2 and column 2, so we increment both those by 1. And finally, the 6 gets painted, which increments the 2 index row and 0th column. At this point, the painted column of 0 is 3, which is equal to the height, signifying that the entire column has been filled out, so we return I. Okay, now that you hopefully understand the code, let's go over the time and space complexity. Once again, letting n be the height of the grid and m be the width, for time we have improved to O of n by m. The m by m cost comes from where we build our value to position map, and also the second for loop which iterates through the paints. In the second for loop, we now only have constant time operations, so that is why our time complexity has improved from the first solution. For space, it stays the same at O of n by m, and that comes from the value to position map that we had in the last solution as well. Okay, that is it for this problem. We went over 2 solutions, a brute force solution, which was slower because we were unnecessarily checking the rows and columns each time we painted a position, and then we improved this by counting the amount of rows and columns painted total instead. As always, thank you for watching and good luck on all your interviews.